Hi everyone. So today we will be talking about the mole concept, which is a chapter in 11th class. So from there, I'm taking two topics today. We will be talking about the law of conservation of mass, and the second one is law of definite proportion. So these are the two laws about which we are going to talk today. I'm not starting with the basics of solid, liquid, and gas because you all are, I think, already very familiar with the topic of solid, liquid, and gas because you've done it in your 9th and 10th class. Okay. So the first thing that we are going to talk is law of conservation of mass. Law of conservation of mass. So this law was given by Antoine Lavoisier. So what he said that whatever mass you're having in the reactant side will be completely converted into the product, because mass can neither be created nor you can destroy it, right? Or it can happen, let's say, not complete reactant has reacted to form the product. So even at that time, the complete mass of the reactant will be the mass of product plus the unreacted part, right? So he said that mass can neither be created nor destroyed. So I've given you the example also that mass of reactant will completely get converted into the mass of product. And even if the complete reactant is not reacted to form the product, even that the statement will be valid, law of conservation of mass. But this statement is not valid at one time. So we'll talk about that also. So there is one limitation also to this. Like you talk about nuclear reactions. I hope you all are already aware what nuclear reactions are, in which some mass will be converted into energy, right? Which was given by this equation E is equals to mc square, which was given by Einstein, right? So Einstein said that some mass will be converted into energy. That means not all the mass is getting converted into the product of the reactant is not getting converted into the product. So because this is a nuclear reaction, so this law of conservation of mass is not valid for the nuclear reactions. Okay. So this is one limitation to this law. The next law that we are going to talk about is law of constant composition, which was given by Proust. Okay. And this law also come by the name of law of definite proportion. So that is the same thing. Okay, so what this law is going to tell us is, let's say we are having H2O. No matter from where you're bringing this water, either from the river, from the sea, from the pond, or from your house, right? So the formula of this H2O, you know that it is going to remain the same, right? No matter if you're bringing it from where, lake, river, sea, pond, where we are bringing it, the formula will remain the same. You know that, right? And so this law of constant composition talks about that in this compound, the masses in the ratio which they're present will remain the same. Like if we take one example of, let's say, CO2, so you know that carbon and oxygen is there. So carbon's atomic mass is 12 and the atomic mass for oxygen, because two oxygens are there, so it will be 32, right? So this is a fixed ratio in which this carbon and this oxygen will be present no matter from where you're collecting this carbon dioxide gas. Either you're doing the experiment, from there you've collected out, or this is the same carbon dioxide which we are releasing. So the formula will remain the same. That means the mass composition will remain the same in this, right? But again, there are certain limitation to this law of constant composition given by Proust. We will be now talking about the limitation to this law. So now let's talk about the limitations. I think you all could have guessed one, because carbon is not only having one isotope. So carbon 12 is also there, carbon 14 is also there, right? So if I say I'm having a sample of CO2, in that, you know that not all the CO2 will have carbon 12, right? It could be carbon 14 also. So isotope was not obeying this law of constant composition. So this was among one of the limitations of this law of constant composition, which was given by Proust. Okay, so this is first limitation. And the second limitation is, also I'll give you an example. Let's take an example of, this is a ether and then this is a alcohol. I think you all can see and tell me that it is having something in similar. Both of them are having two carbons, right? Both of them are having six hydrogen, one oxygen. And here also, again, we are having two carbons, six hydrogen and one oxygen. That means the composition of the formula is same. the mass composition is also same mass of carbon is combining, same mass of hydrogen is combining, same mass of oxygen is combining, but still this is ether and this is alcohol, right? Their properties are totally different. So this is another limitation to law of constant composition, because here we discuss in law of constant composition that the properties of all the CO2 will be same because they all are made from the same carbon atom, same oxygen atom. But here what we're seeing is one is ether and the another one is alcohol. They're made by the same masses combined together, same atomic number, but still we are facing this problem. So these were the two limitations of law of constant composition. I hope it is clear to you all, but if you find still any problem with these two laws which we have discussed, the law of constant composition and the law of conservation of mass, you can either mail me at my mail ID or you can just put your doubt there in the comment box. I will read it and I will quickly reply back to your doubts. So this is it for today. Now we will be meeting in some another session with some another part of this same chapter, the small concept. So please make sure that you all hit that like, share and subscribe button. So yeah, this is it. Take care. Bye bye all of you.